Okay.
Hello, everyone. I'm Eric Gu. I'm from China, Beijing. It's my first time to Indonesia. Sorry, I can't speak Indonesia, but I have many friends in Indonesia. Like my colleague in Jakarta, the co-organizer of the OpenInfra Indonesia user group, we just visit our partner G-Media yesterday. So I'm very glad to be here. I'm the consulting architect at EasyStack. I have many roles about the OpenStack or OpenInfra Foundation. In 2012, I started the journey to OpenStack in IBM. I contributed the Nova driver to support Power VM. Then I contribute to the common library, Oslo. The project like Nova, Neutron, Keystone, they usually use the common library. I serve the PTL in the release, Pike, and Queen. Then I serve the board director of the OpenInfra Foundation. So today, I'm glad to introduce the latest progress of OpenInfra on ARM. In this presentation, I will talk about the three parts. The first about the ARM ecosystem. Then I will share the previous works on ARM in the community. Then the last, I will share the practical experience in production. And the final, I will play a video to run the VM on the ARM server. So as you know, the ARM is dominant force in mobile device like the smartphone, tablet for decades. But in recent years, due to his advantage, such as low power consumption, it began to be applied in the data center. Many big enterprises like the AWS, Marvell, Huawei, and some vendor began to build the CPU based on ARM. And then there are more vendor build the ARM server. So I think the ARM is growing very quickly because it is IP authorization model. ARM company don't produce CPU, but he licensed to many vendors. So many, I just mentioned the big enterprise, they began to use the ARM server. Let's track the process of the adoption in the data center. On the left, there's a picture I taken from the conference in China. It shows the IDC report, the quarterly enterprise infrastructure sharing. The light one, we can see the worldwide server market forecast by CPU type from 2020 to 2029. So the compound annual growth rate of the ARM server shipment exceeds more than 30%. The rate is more higher in the China market, about the 50%. So many companies use the ARM server. So I think the ARM server is evolving and going to mainstream. Let's deep dive to look at the difference between the ARM and the x86. As you know, the ARC CPU has the RISC instruction set. That means he has the fixed length instruction set. It's very easily to load and execute. But for the x86, it has the CISC instruction set means you have variable instruction. It's a little complete. And for the power efficiency side, the ARM server usually have the higher performance per watt. So, and some new generation of the x86 began to closing the gap. For example, from the AMD. There are differences between the lesson model. For x86, only two players, the Intel and AMD. For the ARM, there are many companies like the Apple, AWS, NVIDIA, Marvell, Huawei from China, Samsung from Korea, Fortune from Japan. So there are many vendors to build the ARM CPU. And the ecosystem, the x86 system has the mature software ecosystem. It can support legacy x86, but if you want to run the application on the ARM, you need to rebuild or recompiled with the ARM compiler. So we need to recompile. And the software, I think the software ecosystem for ARM is increasing the mature. And the target market is different. ARM, including the mobile, embedded edge cloud, and the x86 focus on the desktop, laptop, server, HPC. Let's talk more about the software ecosystem on ARM. The right picture I take from the website from Linaro. Linaro is a non-profit organization, consists of the many big company which use the ARM server, and ARM actually invest on the software ecosystem. This is just a part of the software can run on the ARM server. They include the type like operating system, virtualization, cloud, the cloud native, storage, web, database, big data, AI, programming language, toolchain, and many. So if you want to find more details about the software can run in the ARM server, you can just go through the link. But please pay attention. This link is maintained by Linaro organization. If the software is not listed in the dashboard, doesn't mean it doesn't support ARM. So usually, I think most of the software, especially in the data center, can run on the ARM. This is the initial official support version for the Loki. Loki is the standard for the OpenInfra, Linux, OpenStack, Kubernetes, and infrastructure like the SAF. You can see the official support the Kubernetes is the version 1.2020, and the SAF from the L. But pay attention, the lower version can also support the ARM. The next, I want to share the work we have done as a community. We have done to support the ARM. In the community, we have the SIG, specific interesting group, multi-arc. The group is created in 2019, inspired by one presentation. the running OpenInfra on ARM6. I do the presentation and with the Linaro guys in the Shanghai summit in 2019. The goal of the SIG to support multi-arc, not only about the ARM server, but also like the power, the Z mainframe. So making sure the code we write for the OpenStack can run different CPU. So the main work, including provide the documentation to run the CI jobs and checking the issue and fix the issue. So you can find more details from the link at the bottom. The left side image shows the work we have done in the community. So what components can be supported in ARM? This is a briefly introduction. I think most of the component in the OpenStack project can support ARM, like the compute, Nova, Ironic, Keystone, and Horizon. And the networking, Neutron, the storage center, also the storage backend itself. They can run on the ARM server. I list a part of the critical patch for Nova to enable the ARM. The patch usually about the difference between the ARM and x6. x86 has a specific default value. For example, for the default disk controller on x86 is IDE. So, but the default one in ARM is SCSI. If we don't have the patch run the instance on ARM, it will raise error. So the wrong configuration. Another one is the last one for the ARM, the guest VM. The console name is very different from the x86. For example, for the default console should be TTY AMA 0. So it was very different from the x86. So I think I can share more about the feature we support on the ARM server. The basic launch the instance and reboot, migrate, resize, and other operations like that. And the storage related operation, attach, detach, and network. The official website shows the support metrics. You can check the support metrics. Also, I want to say the support metrics is just side what we have supported in official. Actually, some feature like the layer migration is marked as the missing in the support metrics, but actually we can support. There is a limitation, like you can just layer migration from the same CPU between different hosts. That means you can't migrate do the layer migration from the ARM CPU, like the Samsung, to Huawei ARM CPU. We have contributed in the community, contribute to the open source project, but that means all of the thing is done. If we want to deliver to our customer, we may need more issues. So when we deliver in the production environment, we must face some issue. I will share the experience we have to build the product and how do we do the workaround and fix them. Most of them, I think most of them, we start the production very early. The fix has been upgraded to the community project. So if you choose the version like the Linaro website show, you will not meet the issue we face in the early days. EasyStack supported ARM server since 2019. Yeah, this is at least the initial version we support on the ARM. You can find the version is lower than the upstream version. We like the kernel 4.14, the Kubernetes the 1.9.8, and the Ceph the 12.2, and we support the version the Newton and other cloud components. I will share the example problem solved in the early stage. The first one, the case is the live migration. If you want to do the live migration in the ARM, you must specify the configuration. The CPU host most to host pass-through. The default configuration value is none. It works on x86, but it doesn't work on the ARM. And usually the ARM server have the problem. The host UUID is the same one. So when we do the live migration, the libvirt, the component to handle the KVM, will detect the host UUID. If it finds the UUID is the same, it assumes we are doing the live migration in the same host. It's not allowed, so that will lead to failure. So we work around to just set the different host UUID to the libvirt configuration file here. And another example is that when we boot or spawn an instance on ARM server, we found the issue. We found the issue that the console just show gas disabled display. So the fix is set the console type, just the Nova patch, just so that. So when we deploy the ARM server to our customer has many other requirements. ARM server is a new thing. They don't want to invest too much. They want to start a very small cluster. So they don't want the vendor lock-in. So we support the two CPU architecture and several server vendor. At the beginning, we support more and more vendor. At the beginning, we supported the random compute on ARM server. Then the storage one, we can start from the HCI, maybe three nodes to run off the compute storage controller components on the 3 node. But for the existing cluster, usually customer just want to try, so we can just add one ARM server or 2. So that means we must support the one cluster with many different architecture, like the ARM, Intel, AMD, and Hegong is from China, a company. Okay, the workload, we provide a VM, virtual machine, bare metal, and the container. They can share the same network and storage. Here, I will share a real case, the ARM adoption in Posted Saving Bank of China. So the bank is a very big bank in the 2014 Global Bank of 1000 list. The PSBC ranked the 12th in past 2 years. We have sold for this customer since the 2015. So at the beginning, we just provided the cloud on the x86 server. But from the 2021, we start to provide a cluster on the ARM. Until today, there are 12 sets of ARM cluster and 7 sets of mixed ARM and x86 cluster. Until today, the total physical node of the pure ARM server exceeds 10,000. And the biggest cluster, the single one, has more than 16, I think 1,600. So I think this real case just approved. The ARM server is ready for in the production for the data center side. And at last, I would like to share the video. Can we help? Oh, I just click from here. Oh. I think I have the copy in this laptop. I can. Can you play the video on the projector? Yeah. Okay, I can talk more about the ARM server. So this is just one customer. We have many other big companies like the China Petrol, the banking, the security, the financial domain. They began to use the ARM server widely. Oh, okay. So I will explanation. This is the workload we support, the container, the computer storage, and let's look at the detail about the server. Here, I think. Yes, this is an ARM-based CPU, the Node 1. We can find the detail. This is the Wonder model. And the CPU model, Feiteng, another company in China. So we can show more hardware information here. Disk. So the behavior of the OpenStack running on ARM server is the same with the x86. The next, I would like to create an instance and do the layer migration between different nodes. Okay. So I choose the image, the Rocky 9, the open source one, and choose the flavor here, and choose the storage, the root disk. then I create configuration the network. I just used one share network. The worker can just directly connect to the internet and choose the default security group. Then I will set the name here, maybe instance arm, and set the password. Then we can confirm the configuration. Just launch the process to provisioning of the instance. Okay, we can find the instance here in the status creating. Now he finds the node 2, the physical node, and now he begin to the active. We can look more the details about the instance. Just click into it. The summary shows the name and other. So the starter mode, you can see that the ARM only support UEFI, not legacy. Don't support legacy, the flavor. And the root disk, the storage, and the network. Then I will log in the VM and to check the CPU type. Here we can click to the VNC console and log in into the command line. I think, oh, okay. Just LS CPU, you can see it, the architecture is ARC, and there are two nodes, two CPU, 0 and 1. And then it lists the feature or the flag for the CPU. Okay, the next I will do the layer migration. This operation is marked as missing in the official website. This all the operation we can execute, like the resize, the network storage, and something like that. Just live migration. We can choose the destination node. We can choose the node 1. We have some option to quicken the migration process. Okay, you can see it's still on the node 2. It shows the migrating status, the 0 from the 0. Almost finished. Now it node the facing node 1. Then we can log in the VM again. We can see all the thing works well. So we just finished the migration on the ARM server. So that's all. Thank you.